Done?
Yes, sir.
Okay. Yeah. So Science and Tech Current Affairs, October, first part. Yeah. First thing is about traditional medicines. Okay. So apart from allopathy, all the medicines that you take, or modern medicine, there are also some traditional medicines that we will be learning about. Now, recently why it is in news? So recently, Ministry of Ayush have inaugurated India's first integrative oncology research and care center. Basically, for cancer treatment, they have this center. Now, this is an integrative system. It means it has the traditional way of treating the cancer, that is the oncology, modern oncology that comes from the modern ways of medicine. Also, it has other mediums, for example, Ayurveda, yoga, physiotherapy, diet therapy, all these which are form of traditional medicine. So, it has physiotherapy and modern oncology, which are proper developed modern sciences, and Ayurveda, yoga, diet therapy, all others which are helpful traditional medicine systems. Okay. So, both are being combined under a single center that will be treating different kinds of cancer. Now, then what does Ayush include? So, Ayush is a ministry, if you know, it was started in 2015. This is a ministry of Ayush. Now, Ayush stands for what? So, Ayush stands for A for Ayurveda, Y for Yoga, U for Unani, S for Siddha, S is for two things, Sova Rigpa and homeopathy. So, this is Ayush. Okay, that's why the name Ayush is given to it. Now, we will read about little bit about all of them. Okay, Ayurveda, yoga, all of them. What are they? Very basic, 1-2 lines, just what we need. Okay, then okay, first is this, that is Ayurveda. Okay, now Ayurveda is believed to be existing from a very ancient times. Now, it was started being compiled in Samhita period, that is a more structured form came in around 1000 BC. Then Lord Brahma is referenced as the first proponent. Okay, then in Ayurveda there are two important texts, one is Charak Samhita and other is Shushruta Samhita. Okay, these are the two fundamental documents with respect to Ayurveda. Now, there are many specialities, this that. Now, there is Punarvasu Atreya, which is physicians, which treat usual whatever issues you get, all those diseases are treated by these. Then there is also Divudasa Dhanvantari, which are the surgeons. Okay, Dhanvantari, these are all famous doctors of those times. Okay, so then their name came as Divudasa Dhanvantari. Surgeons are called as this. Now, branches, there are many different branches, you need not remember the names of all the branches. Now, there is something called dosha. So, there are three kinds of doshas. So, Ayurveda believes that everything or entire human body is made up of 5 components. The 5 usual ones: air, water, earth, ether and fire. So, all these are the main components. Now, Vata Prakriti, so there are 3 Prakriti or 3 different kinds of people. Now, Vata Prakriti people are the one which are very thin, okay, and they will be very agile, but they will be little restless. So, they are made up of these 2 components. Then you have Kapha, which are made up of earth and water. Now, these will be what? These will be little like slow people, they'll have more tendency to become fat and all. Then you have fire and water, so that neutralizes everything. So, mostly these people are what? Athletic and that way. So, they have divided the body in these ways. Now, originally in traditional way they are not considered one is much better than the other, what they have is there are different treatments for each of them. For example, a person who is of Pitta Prakriti, that means he has a lot of fire in him. That means in the real way, if you see, these people are very fit, so they have high muscle density. So what will happen, even if they eat more, it will get dissolved, correct, and their body also needs more nutrition, so they must eat more. These people, they don't have fire in them, or their body is in such a way, metabolism rate is not that high, so they should eat little less. So they both can be managed. Similarly, this also can be managed. So this was the way Ayurveda used to deal with it. Then we come to yoga. Now, yoga or naturopathy. So yoga comes from India. Naturopathy was a similar thing that we see in case of yoga and Ayurveda, similar thing propounded in the West. So it also talks about the 5 elements: earth, water, air, fire and ether. Now yoga has 8 limbs or ashtanga. Now understand, so yoga in traditional way, what we see yoga, we see yoga as asana, dhyan and pranayam. These are the 3 things we usually associate with yoga, correct. Apart from that, there is also yama, niyama, samadhi, pratyahara, dharana. So all these are also parts of yoga. That is why the modern version of yoga that you see in the West is not real yoga, where they wear that yoga pants and start doing exercises like this. That is not just limited to yoga. Yoga is much more holistic development of a human. So it has many different components. All you need to remember is ashtanga, that is 8 components are there. Then approach is what? Basic approach of most of these traditional medicines is that this involves self-healing. So yoga, naturopathy as well as Ayurveda, they believe in self-healing. So basically they will supply the body what nutrients, what dosha is there in the body. To cure that, they will provide something nutrients, instead of fighting the entire system. That if your body is producing, let's say some kind of disease is being affected to you, then you will be given many antibiotics to just kill it. While this believes in natural process of the body. So body always has natural processes also to deal with the pathogen or anything. Now what part of the body, for example producing antibodies, what part of the body deals with it, they try to enhance it. Okay, for example, let's say your body has some acidity kind of issue you are having. Now one way is you take acidity medicines that will try to neutralize the acidic behavior that you have. Other way can be that you try to enhance your gut bacteria by eating food that are good for your gut. So eventually your body will take over and you will get over acidity. So this is the way of Ayurveda and naturopathy. Then this is of course person centered rather than disease centered. So basically it will depend on the person. That is why different kind of doshas, this, that was mentioned. So it was actually personalized treatment. Much before this term became popular. Okay, now then you have Unani. Now Unani was developed in Greece. Main person was Hippocrates. So this was the main person who developed this method. Now, but it was much more popularized by the Arabs. Okay, so the Arabs and the Persians, they popularized it. Originated in Greece by this person mainly, and then Arabs propagated or developed it much further and made it popular around the world. Now, so this is one person, other is Galen. Then theory is what? They have some 4 humors theory, that we had those 5 components theory. They had blood, phlegm, yellow bile, black bile. So they have some different theory. You need not remember all of them. Not comes from India. Then status is what? So it is officially recognized in India as an alternative health system. So we have recognized this. That is why it comes under Ministry of Ayush only. So it can also be regulated. Everything is there. Not from India, but accepted officially by India. Then Then you have Siddha. Siddha comes from southern part of India, comes from South India. This is Agasthyar is regarded as the foundational figure. Now, this also has some different practices, electrochemistry, medical practice, yogic practice. They have divided it into something. Again, not very important to remember all the different components. Now they also have some diagnostic methods like 3 humors and 8 vital tests. This that need not remember. Very less chances of being asked. Now, care is again, it is very similar. It is very similar to what we are doing in Ayurveda, but similar test, similar thing is there. But this comes from more from the southern part of India. That's it. Similar. Just the name is important. Then homeopathy. Homeopathy is very famous. Okay. Homeopathy comes from the Europe. It comes from Europe, homeopathy. Then it got popularized around the world. Now, founder or codifier is Dr. Christian Frederick Samuel Hahnemann. Now, need not remember the name. Only thing you need to remember comes from Europe. Okay. Then sources are remedies are prepared from natural substances, plant, minerals, animals, like this. Okay. For example, if you might like when I suffered from jaundice, okay, so they were giving me some Ayurveda medicine inside a banana they usually give. Okay, so I was eating it. Okay, and then my mother also started homeopathy part of it. Okay, and then they were also giving me some Ayurvedic juice that I was having. Then I got the this homeopathy medicine also. Then when I started eating this homeopathy medicine, it felt like the taste was same. Then we bought the liquid because we wanted to get over early. So when I drank it, it was exactly the same thing. So basically Ayurveda as well as homeopathy were in a way subscribing to a same plant or an extract from that same plant that helps curb jaundice. Okay, so it is very much derived from natural substances, plant minerals that you find in Ayurveda. Similar are there in homeopathy also. Just it is given in that meaty goliyan form. Okay, just the form is changed. So what they give you this sugar balls like this, and over it they drop it 1-2 drops. Okay, that's why sometimes it is said that it is mostly placebo. It does nothing. Mostly it is placebo. People start feeling ki better ho raha hai, so then they get better. Otherwise, the thing that if you are going to try homeopathy, what you can do, you can go to that homeopathy shop and ask him not to give you this meaty goliyan, but the 2 drops that he drop, buy that only. That is basically the more extract form which you need, so that you can take. Now, India timeline introduced by European missionaries in the early 19th century, officially recognized in 1948. See, this is also officially recognized. Then key principles are not so important. Then you have Sova Rigpa, just the name is important. This comes from the Indo-Tibetan knowledge, that is from the areas of Himachal Pradesh and Tibet. Okay, now this was developed 2500 years ago. Now this is very similar to the other practices we have. Same different kinds of herbs, plants we'll use, same kind of understanding of human body, just the name is important. Then, of course, this is also recognized, that's why under Ministry of Ayush. So 5 you anyway understood. First is Ayurveda, then is Yoga, then is Unani, then is Siddha. Siddha, along with Siddha you can remember Sova Rigpa also, and with that is homeopathy. So these are the 6 main. And along with Yoga you can remember naturopathy. That's it. Then you come to Indian diet issues. Now this is a Karnataka thali. Okay, very nice, very tasty. But there is an issue that has come from the ICMR study throughout the Indian diet, from the northern point to the southern point. What is happening? We consume a lot of carbs. Our 65 to 75% diet is entirely carb. This is carb, this is carb, this is carb, all this is carb. This is oils. So these oils are also usually not good. We'll study about them also. So all these are carbs. not very good for you. Even when we were eating curd, okay, then also we add elements of carbs and saturated fat, means oils and all this, okay. So it is not very healthy, okay. Need not be very nationalistic about it. Our food is very tasty and all, but it is not so healthy, especially the kind of thalis that we have started having now, okay. These are not the traditional ones. White rice, okay, this wheat that we are using, these are not traditional ones, okay. Neither the white rice was used in southern India, neither this wheat was being used in northern India. We were mostly using different kind of grains and cereals, okay. Then what is the core finding? Now, the ICMR 2025 study flags Indian diets as carb heavy, high in saturated fats and low in protein, driving non-communicable diseases. Now, these are the three main things in this only, understand. One is carb heavy. So, our 65 to 75% nutrients comes from carbs, which is absolutely not healthy. Second thing is high use of saturated fats. Saturated fats, example, ghee, different kinds of butters, all these are what? Saturated fats, okay. The difference between saturated and unsaturated, that we will see in science and tech. So, saturated fat, for now understand that saturated fat is not good for you. It causes bad cholesterol, it causes bad cholesterol to increase, okay. So, because of this, bad cholesterol increases. This is the issue with high in saturated fats. Now, next is low in protein. This is very famous. Our diet is very low in protein. Our major source of protein, especially for the vegetarian diet, is dal. Dal is a good form of carb, okay. It has components of protein, but not that much. It is not worth to eat many cups of dal to get that small amount of protein that you can get from a egg. Otherwise, for a vegetarian diet, you should take milk based products, for example paneer, tofu or soya bean. Soya bean has a lot of protein, so entire change is needed. Now, this is doing what? This is driving non-communicable diseases. What are non-communicable diseases? Diseases that are not transmitted from one person to other. For example, diabetes, for example high blood pressure. Now, high blood pressure, or let's say I have diabetes, I touch you, you won't start getting diabetes, but so that's why they are called non-communicable diseases, okay. That is, they come mainly because of lifestyle issues or hereditary issues. That is, comes to you genetically or because of your ill health. That's it. Then, what are low quality carbohydrates? See, refined grains, that polished refined grains. Now, added sugars with low fiber and low micronutrients, these are low quality carbohydrates. Examples are white rice in excess if you eat, maida, okay. Then sweetened drinks, desserts, ultra processed snacks, everything that is tasty is not that healthy, okay. So, this is low quality carbohydrates. Carbohydrates also have different qualities. We will see high quality carbohydrates also, okay. Then, for example, jowar, bajra, these are high quality carbohydrates. So, even if you want to take carbohydrates, earlier Indians used to eat all these mixed grains. Now, we have shifted to rice and wheat system, which is not that healthy. Then, what drives saturated fat intake? This I have already explained you. Palm oil heavy, butter, ghee, vanaspati ghee. Vanaspati ghee is what? What you usually know by the brand name dalda, okay. Vegetable, this is vegetable ghee, vanaspati ghee. Now, all this is now raises LDL. LDL is nothing but what you had written, bad cholesterol. And if cholesterol increases, there is higher risk of cardiac issues. Then, why is protein intake inadequate? Because our plate is mainly dominated by cereals. All these are very small portion or skipped. Those are those which are rich in protein. Now, of course, cost is also an issue. Lack of simple proteins, all these are there. Vegetarian diet is also an issue, because vegetarian diet provides you sources of protein, but only if you have enough money. Otherwise, there are no cheap sources to get protein in large quantities. Then what are the health implications? So health implications will be what? First is obesity, then type 2 diabetes, then all these hypertension, fatty liver we'll see also. Okay, so all these are different kinds of diseases that are caused. What dietary shift help immediately? What are the dietary shift we should take? See, carbs. We should change the quality of carbs that we take. For example, we can swap to whole grains. Okay. Examples are using atta or brown rice. Okay. Then we should take more vegetables and salad with each meal. This can be done. Now, vegetable salads, all these are also carbs, but they are much more healthier carbs. So this we should take. Then next is fats. So fats, what we should take? We should take unsaturated fat, not the saturated one. Unsaturated fat. Example are mustard oil, groundnut oil, till oil. Okay. So all these we should take instead of the palm oil and other kinds of oil that we are using. Not so good. Then sugar. We need to cut back our sugar consumption. Correct? Different kinds of replace sweet beverages with water, chaas, whatever. So basically consume less of sweet. Refined sugar especially is very, very dangerous. Then then you come to non-alcoholic fatty liver disease. This is non-alcoholic. Non-alcoholic. That means, now mostly liver issues, when people talk about liver issues, what is the first thing that comes to our mind? Is it is being caused by drinking excess of alcohol. Okay, but there is something called non-alcoholic fatty liver also. That is, even without consuming alcohol, you can have some issues in your liver. That we understand. Now, see, just word background. Non-alcoholic means alcohol nahi le raha hai. Then fatty liver. Fatty liver means what? Liver will start having some layers of fat. So this is what is NaFL, that is non-alcoholic fatty liver. As you can see, fat accumulation is there in the liver. So this is fat accumulation on the liver. This is simply non-alcoholic fatty liver. Then if it goes bad, then if the fat accumulation continues to a lot of point and then it starts having inflammation and scarring also. Inflammation or scarring matlab chot lag jana, okay, from anywhere it starts, or it gets more, kya bolte usko, it gets bigger in size, okay, because of something that gets hurt. Now this is steroporesis, okay. Then after this, if it goes even further, even bad, then you get to cirrhosis. Now in cirrhosis, you have scar tissue that replaces the liver cells. So instead of the normal liver cells, you start having all these scarred tissues or scarred cells. Eventually this becomes, if not stopped, eventually this becomes liver cancer. This is the chain. Now we'll understand each of them little. Now non-alcoholic fatty liver, I have had this, okay. This you can have after having many different kinds of, like when I was in college, I started eating a lot of these chips and soft drinks and everything, okay, and especially at night when we used to watch movies and all. So what happened? In the first 6 months, my body somehow managed. I kept eating it and then all those drinks, Sting and all, everything I used to drink, then eventually my liver got affected and I started having fatty liver and then many other things. Then there, when I was in the hospital, the doctor was constantly asking that, do you drink alcohol? Okay, because the treatment will be slightly different, correct? So she was constantly asking that maybe I am hiding. So next morning also she came to my bed and she is like, do you take it? So I wasn't taking alcohol then, but so this is a disease that you can have even without taking alcohol. Now, what is non-alcoholic fatty liver disease? See, as I explained you, a condition where fat accumulates in the liver without alcohol involvement. Simple. Includes. This includes two types. One is non-alcoholic fatty liver. This is the first and the basic one. And non-alcoholic steatohepatitis. This is NASH. Non-alcoholic steatohepatitis. This was the second one that we had seen. After that, there was cirrhosis. So cirrhosis we are not talking about. Cirrhosis is already a very bad disease. After that, you get liver cancer. Then, what are the types of it? So NAFL is what? This is fat buildup in the liver with minimal to no inflammation. As we saw that it had fat accumulation, but it had no inflammation or very little inflammation. Then this can cause liver enlargement and discomfort at max. So maximum what it can do, just enlarge your liver a bit and some discomfort you will start feeling. Okay, not very serious here, but if you continue, then you will start having this. Okay, which is steatohepatitis. Now here there is fat buildup plus liver inflammation. Okay, then this can lead to liver damage or liver fibrosis. Fibrosis is what? Excess scar tissue. So presence of scar tissue increases. After that, it can also cause cirrhosis, which increases the risk of liver cancer. Understood? It can lead to much fatal illnesses. Then what are the causes? Causes are very simple. What will be the causes? First is excess body fat, belly fat, overweight or central obesity. Okay. Now next is insulin resistance or type 2 diabetes. These are also linked. Obesity and type 2 diabetes are also linked. Now, so makes the liver store more fat. Then you have high calorie, refined carb, basically bad diet. Then sedentary lifestyle, not moving anywhere. All these are connected. Correct? Then abnormal blood lipids. Then you have genetic predisposition or family history. Now some people may have family history of this. Because of that, they start getting fatty liver issues. Okay. Then last is hormonal or medical condition. Now different conditions like PCOS, okay, all this obstructive sleep apnea. So all these other can also lead to. Major cause is this. That is not having proper nutrition, taking things that are not good for your body, especially the sugary ones. That increases blood sugar level in your body. So once you gain fat, start consuming all these food, then you have a high chances of developing non-alcoholic fatty liver. Then how you can diagnose it? By simple physical examination, medical history, this, that. Then how it can be managed? So as we understood, first thing is weight loss. Okay, weight loss is a key to manage non-alcoholic fatty liver disease. It's the most important thing. Then once you start losing weight, your body starts repairing itself. Okay, so this is the most important thing. Of course, if it becomes chronic or some higher disease like fibrosis or cirrhosis you start having, then you continue with the treatment, but over time you can get over it only with a lot of weight loss and start consuming good things. For example, when I started having this, then I developed hepatitis B also. Eventually your body starts losing weight. Okay, so if with this, so weight loss can also be caused by your body itself. So my body, because I was young at that time, so my body knew how to repair it, because that was not a age to get fatty liver disease. So my body started losing weight on itself. I was losing half a kg for a few days, every day. Okay, so eventually it got cured. Then, so main thing is losing this weight only. There are not much medicines. You have to maintain a healthy diet for a few months. Eventually you get over it. Then, yeah, then you come to astrosat. By word breakdown, what do you understand? What would astrosat do? Sat means what? Satellite. Astro means what? Will come from astronomy, not astrology. Will come from astronomy. That is, it will try to study the outer space. what we do in astronomy, correct? So that it will try to do using a satellite. This is astrosat. Now why is this in news? So astrosat, this was sent by ISRO. This was developed by ISRO. Partners are, there are some different partners, not important. Sent by ISRO, that is made by India. Now astrosat completed 10 years on 28th of September 2025. So it completed 10 years, marking a decade of space based astronomy for India. Okay. So for a decade now it is observing different phenomena in the space. Now when was it launched and what is its mission like? So launch date you understood, 28 September 2015, 10 years before, launched by PSLV XL, PSLV C30 XL from Satish Dhawan. This is fine. Then now it was designed actually for 5 years, to last 5 years, but of course because of being much more fuel efficient, it is still continuing to give us results. Okay, you will understand that satellites usually get most of their energy from solar. So if their panels and everything is working fine, then they can work for much longer also. So 5 years was the time period they had decided, but it is still continuing to give us results. Now what is astrosat? So this is India's first dedicated space astronomy observatory. See, space observatory is nothing but simply space telescope. That is a telescope that is in space. Space observatories are this only. Now telescope, you understand that telescope, people you might have seen. Okay, it's a chhat pe leke people are doing this, okay, on the terrace. This is telescope. Now this is a much smaller telescope. Now it has a good resolution, so you can still see something that you can't see with naked eyes. Now the space telescopes are much more advanced than this. They are much bigger also, and they try to capture images in the space. So they will go to the outer space and then it will take images. Now not the images like, let's say this is the telescope. Now it won't take image of something, ये इधर से कुछ celestial bodies आ रही इसकी photo ले ली. Not that. It is basically because space is too vast. Now you cannot just take what is being observed. Only that picture you need not take. What you need to take is absorb or understand all the radiations that is coming from different directions. So from here, if it is constantly getting radiations like this, then it can predict that there is some body like this, some star like this. So basically it is not seeing anything directly. Instead what it does, it just understand all the rays that is coming towards it. Based on that analysis, it is able to predict. Different things are predicted by it. Now see, now you see this. So capability is multi-wavelength observatory with 5 payloads. What it does? Multi-wavelength observatory. Now see, spectrum is far UV. So basically all these are not visible. Only visible light is visible to you. Correct. Now here far UV, near UV, visible, soft X-rays. So all these different radiations that are coming from all different directions, it is able to observe them. This is how they work. And hard X-rays. Mainly the focus is with UV and X-rays. This is astrosat. Now so usually what they do, they just send this very far to a few million kilometer above, far. Then what will happen? Then from there, let's say 1.5 million kilometer far from Earth. Now this satellite is here. it does not care about the earth. Only thing is, the information is getting relayed here. Now it is going here round and round, and it is observing the outside world, and it is observing the outside world. Now all the radiations that are reaching him, it is trying to observe the outside world using it. Then this is what a telescope does. Now just the information is relayed back to earth. So they are very far observing the outer space, information is getting relayed to us. Now what they will tell, it is going around somewhere in the outer space, then suddenly information will come that it has found a new kind of galaxy, a new kind of planet or planetary body, a new kind of this. So all this information keeps on coming. This mainly helps us understand the universe. This is their main feature. Mostly the satellites that India sends are for what? They are for earth uses. For example, some are used for communication, satellite TV, satellite internet. Okay, so all that we use for measuring rainfall, when we will have rainfall, climate, weather, all those predictions. Those are the satellites that are for earth uses. This is for understanding the universe. Okay, so that is why it is said India's first dedicated space astronomy observatory. Now, what are its scientific contributions? Now, not very likely to be asked what are the scientific contributions of it. See, this is our first attempt or initial attempts at doing something. Now, whatever we are discovering or this astrosat is doing, some people's or some different countries satellites have already done. Okay, so anyway, for the first time detection of FUV photons from galaxy, this that, just normal. Now, good thing about it is, which you can remember, its spectrum is very wide. That is, from UV to visible to high energy X-rays, everything it can observe. In the next topic, we will see that there are some observatories that can observe only in one of these. That is, they can only observe UV, they can only observe visible. It is able to observe all three of them. Okay, then what are the payloads on board? Now, so there are 5 payloads on board. Ultraviolet imaging telescope, okay, UVIT, need not remember the names as such, but just see. So this is large area X-ray proportional counter, then cadmium zinc telluride imager, then soft X-ray telescope, then scanning sky monitor. Just see the name once, something will stick in your mind, otherwise not needed to remember exactly. Then yeah, now we come to something called space observatories. Now we have understood in case of India, that is astrosat. Now you see the entire mechanism of it, space observatories. Okay, that was in news. This is a static topic, but we should cover it. That is space observatories. Now, space observatories are what are they? They are telescopes in far space. Now, it looks like this. So from the top, it looks like this. So it has sun shield here. So see this. Yeah. So if sun is here, let's say this is sun. This is sun. So it will be like always like this, because the sun's energy is very high in space. They don't have the ozone layer and this that, nothing they have. So sun's energy is very, very high. Very high temperature is coming. So it will always be like this, opposite to the sun. Now this is this part or the back of it, and you can see solar panel also here, because it needs to get energy also from the sun. So from here it is getting the energy also, and other parts it has to protect. That is why it uses different kinds of metals here, okay, to maintain the temperature here, so that all the light that is coming from the sun in this part gets reflected back and it does not heat it, otherwise it is very hot, it will burn. Now, so it will always be like this. And now on the other side you will have something like this. That is why this is called the observing side, that is called the sun facing side. So sun facing side is flat, just trying to block the sun light, and there is one solar plate so that it can get energy from the sun. Then observing side. Observing side is what? So it has mirrors and some scientific instruments. Now what it will do? So all the radiations that are coming towards it, it has a big mirror. Okay, different telescopes have different size of mirror. By size here I am talking about, some have the size of mirror of, let's say, of a bus, some have a size of a tennis court, some have a size of a badminton court. So that big I am talking about. So that is the extent of mirror they have. Now, so with this mirror they are trying to observe different kinds of things. Okay, whatever rays are coming towards it. Now this is mainly made up of very thin gold. Now what it will do? Gold mirrors are generally used because it is very sensitive to infrared radiations. Now infrared radiations, that is, it will reflect all the infrared radiations. Now infrared are very important, you will understand it, because most of the observations that are hidden, they are only releasing infrared rays. Okay, they are not releasing ultraviolet. Ultraviolet rays are being released mostly from places that are generating energy on its own. For example, stars and all, planets and all these are generally releasing infrared rays only. For example, you might have heard that Earth's, when you might have drawn this diagram, that from the sun you get UV and visible light, but from the Earth what is reflected? Infrared light. Okay, so planets and all these bodies always release only infrared radiation. That is why you have to observe the infrared radiation. So this is made up of very high quality of gold. Gold has one very good property. What is one property good here of gold? Yeah, other property is gold is non-reactive. Correct. So anything, gold is a noble metal, it does not react with anything. So also it does not form oxide layers, this, that. So it will remain clean as it is. Okay, because it does not get rusted, it does not react with anything. That's why gold is used. Otherwise, if any other metal you will use, so many things are in the outer space, it can get hampered then. This is the observing side, sun facing side. Now, what is this Great Observatories program? So this was a program that was started by NASA. Now it consisted of 4 large space-based telescopes. Now each built to examine a specific part of the electromagnetic spectrum using different technologies. So NASA came up with this, that we will develop 4 different space telescopes in 1990s. Now what those 4 telescopes will do? Those 4 telescopes will be dealing with different kinds of electromagnetic waves or radiations. For example, some will deal with infrared, some will deal with UV, some will deal with visible, like that. Okay. Now then next, now the names of this are important. What are the great observatories? One is Hubble Space Telescope, you might have heard. Hubble Space Telescope, what it observes is visible and near UV, visible light and near UV light, almost ultraviolet lights. Now later infrared capabilities were also added to it later, but initially it came for visible and near UV. Then you have Compton Gamma Ray Observatory. This is not in use now. It was deorbited in 2000. Some malfunction was created. So this was to observe gamma rays and later hard X-rays also. Then you had Chandra X-ray Observatory. Okay, don't get confused. This is not from India. This is from NASA only. This was the name of the scientist. Okay, he was an Indian American scientist. That's why on his name they have given this. So Chandra X-ray Observatory, again from NASA only. Soft X-rays, it was launched in 1999. So it was dealing in soft X-rays. Then last is Spitzer Space Telescope or SST. This was dealing in infrared. Okay, so different radiations are being dealt by each of them. That was their plan. Now, why is Hubble significant? So, now it provides extremely high resolution images with negligible background light. Now, understand this, how these telescopes provide very high definition photos. So, there are two things why they produce such good photos. If you might have seen photos of some celestial bodies, they are very clean, very beautifully shown. Now, how does that happen? Understand, there are two things. First is the distortion is very low in outer space. On Earth, when we are living, there is atmosphere, there is so much dust particles, pollen, this, that. So, there is a lot of distortion. That is why photos are not that clear. In the space, there is very low distortion. So, whatever light is coming, that is not being distorted. That is why you get much more clearer picture. And second thing is their extremely large size. And continuous observation. Now understand this. See, this distortion you understand. For example, you might have, if you see cricket, you might have seen that when matches are there in Australia, the video footage is very, very clear or much better than that of India's when match is in India. Now, it is not because BCCI is not buying the good cameras. We have the good cameras, everything, but if you are playing a match in Delhi or Kanpur and the AQI is 280 or 380, then that means AQI is, so air is not clean. So, how you will get the clear images? That is why the video quality is low. When you are playing in Melbourne or Sydney, they have AQI like 9, 11. So, they have such low AQIs, that is why picture is much more clearer. Now, that gets, now in space is definitely much more clearer than Sydney or Melbourne also, okay. So, the distortion is very low. Other thing is large size. Now, usually the camera lens that I have on my phone or you may have on your phone, this size, correct. Even the iPhone, this, that will have 2-3 lenses, small. Now, big lenses you might have seen, like the big cameras have, like DSLRs, they have this big size lens. Now, think about size of lens that is as big as a tennis court, a lawn tennis court. So, this is a much bigger lens. So, it will take much better pictures. Other thing is continuous observation. That is, it is continuously observing. Now, usually when I take a picture, I just click it. So, my camera observe this for a millisecond and captures it. Now, it is doing what? It is continuously observing it over days and years and months, eventually to get that one footage. That is why it is much more clear. Then deep visible images, okay. Then next is breakthroughs, accurate determination of expansion rate of universe. So, basically understanding of universe, it is expanding. Then servicing is done. These are the main things about Hubble telescope. Now, of all these four, the most important one is this only. That is a lot in news and also very important. Now, after this, we come to something called James Webb Space Telescope. This has been sent very recently, 2021, James Webb Telescope. Now, this is the most advanced. If you see, those were sent in 1990s. This James Webb Telescope is the most advanced one. Now, it is an international collaboration of NASA, ESA and CSA. CSA is what? ESA is European Space Agency and CSA is Canadian Space Agency. So, all these three combined forces, they have made James Webb Space Telescope. This is the most powerful that we have right now. The largest, most powerful and most complex space telescope. Now, this is also an infrared telescope. Okay, and it has a 6.5 meter primary mirror. 6.5 meter, you understand, 6.5 meter, almost size of a tennis court. That big is the mirror. Now, this is also infrared telescope. Now, location is what? It operates at Sun Earth L2 point. Okay, so basically there are certain points between sun and the earth which are, see, at some points, just crude understanding I will give you, this is Lagrange points. So what happens, there must be some place here where earth is attracting it and the sun is also attracting this body because of gravitation. Somewhere they must make up equal. So these are the points where the gravitational force of earth and sun becomes equal. Now what will happen, if the gravitational force of earth and sun is equal at these places, if I put something here, what will happen, it will not move, so it will stay at its place. Otherwise, because of the gravitational pull of the earth, everything starts rotating about the earth, or because of the pull of the sun, it starts rotating around the sun. If it is getting nullified, it will stay at its place. That is why now you want to observe something for a long time, so you want it to be stationary. So that is why they are usually kept at Lagrange point. So this is kept at Lagrange point 2. Then now, what are the major technologies? First is the primary mirror. Okay, this is again gold coated. This is 7 times, this screen collectible area is more than 7 times that of Hubble telescope. So much larger than that. Now, sun shield. As we understood, sun shield has to be there, otherwise it will be destroyed by the energy that is being released by the sun. Now, then you have cryogenic operation. Cryogenic operation as in that it is being operated or it remains at very, very low temperature, that is minus 232 degree Celsius. Why? Understand that whenever a body has heat, like you are also releasing infrared radiations. Now if I have heat, it will be released in the form of infrared. That is why it has to be at very low temperature. Otherwise kya hoga? Now you have this, and you have to observe some infrared radiations. Now this satellite itself is releasing infrared radiations. So what will happen? They will entangle and you won't get the correct results, because itself it is releasing infrared radiations. So they will reduce the temperature, they will keep the temperature so low that the infrared radiations being released by the satellite is almost negligible, to observe it clearly. That's it. Then unique achievements. So first thing is exoplanet CO2, for the first time, first unambiguous CO2 detection has been done by this. So in one planet they have found CO2. This is one, so it is an observation satellite. So in at one place or one planet they have observed CO2. Similarly, it has observed this CH3 plus ion also, that is methyl cation also it has observed. Why it is important? Because it has carbon. Carbon is the basis of organic chemistry as well as life. That is why. So all these are observations that came from it for the first time. Now deepest infrared views, because of course this is the most advanced one. So deepest infrared waves are being observed. That's it. Then then we come to questions. Okay, do it. See, all the statements are, you need to find the wrong statement in this. Which one is wrong? What do you think? Yes, third one is wrong. Good. So third one is wrong. Why? Because it comes under Ministry of Ayush, not Ministry of Health and Family Welfare. Correct? So third is wrong. Other two are right. It is in that Indian Institute of Ayurveda, Goa, and it integrates all these. This was the basic points. So 1 and 2 becomes the answer. Then Again, which one is incorrect? Third one is incorrect because these are also included in Ayush. Allopathy is outside, correct? That's correct. So first and second are correct. Then third one, do this. Yes. Second one is wrong. Reusing or refrying of oil is bad. So what happens? Now even if you take a good oil means what? Which are unsaturated. So unsaturated oils are good. We had seen some oils like groundnut oil, this, that. So these are unsaturated oil. These are good. Now what happens when you heat it? Okay, through the process of hydrogenation, this, that, it becomes saturated. Okay, it becomes saturated oil. That is same as the other bad ones that you have read about. So it also becomes saturated. That means it becomes bad. That is why we usually say na ki don't buy something samosas and all this from outside because वो same oil में use करता रहता है. So that is why this is wrong. Other two are correct. This becomes the answer. Then yeah, not necessarily. Okay, this NAFL typically and directly culminates in liver cancer? No, they do not typically convert into liver cancer, only if you don't do anything about it. आपका वही चल रहा है कि you are eating all those, you continue to do your bad habits, then only it will be converted into liver cancer. It was a long process. It started from NAFL, then you got to NASH, then you got to cirrhosis, eventually you will get to liver cancer, correct? So it's a long process. So third is wrong. Then yeah, it is not exclusively for radio astronomy. It does many different kinds of astronomies, infrared, this, that, all kinds of different astronomies, different works it is doing. So this becomes wrong, 1 and 2 becomes correct. Correct. This is the most important part. From far UV to hard X-rays, everything is covered here. Then last. Huh? Which is incorrect? Or is there anything incorrect? This you have written down. Okay. So first is the program comprises of 4 large space telescope. Yes. James Webb Telescope is outside this program. Next is Spitzer observes primarily in infrared. This is correct. Correct. Then Chandra is primarily a gamma ray observatory. What is this? This is X-ray. Okay. So this is Chandra is also. Chandra is primarily a gamma ray. Let's see. Chandra. Yeah, Chandra is what? Chandra is soft X-rays. Then what is gamma rays? Compton was gamma ray observatory. Now this has been deorbited also. This you please remember. Okay, just the names and what are they observing. Other things you can forget, not the details of it. That's it. Then yeah. Third one is what? Why? Yeah, so it is much more far. Low Earth orbit is very near to Earth. It is placed million kilometers away. So this is wrong. This is correct. This is also correct. Becomes okay. Main things that we did today. First one was, first thing that we did was, first topic was, yes, traditional medicine. In that there was Ayush. What you had to remember? All the 7 names. So Ayurveda, Unani, then Yoga, Naturopathy, Siddha, then Sivorippa, then Homeopathy. So these were the 7 types. Now there were 2 important books, Charak Samhita and Sushrut Samhita. Okay. Then after traditional medicine, what was the second topic? Yeah, Indian diets, very basic thing, very high in, one issue was very high in carbs, other issue was, yes, use of saturated fat, and third issue was protein intake being very low. So protein intake being very low. These were the 3 major issues. How you can curb it? Understand, you have to take much more proper diet, avoid sweetness, this, that. Then next was what? Yes, non-alcoholic fatty liver. So this we had seen the entire system, NAFL, then NASH, then cirrhosis, then liver cancer. How you can treat this? Most important way? Weight loss and proper diet. These are the main things. Okay, then we have AstroSat. AstroSat was what? This is India's first astronomical, purely dedicated astronomical satellite. Then what it has? What rays can it observe? From far UVs to far X-rays. It can observe all of this. Okay. Then what else? What else is about AstroSat? Yeah, this is a space observatory. Now, after this you had different space observatories that are important around the world. Different space, or here you had one program that the NASA started. It had 4 of them. 1, 2, 3, 4. Now just remember all 4 of them and their related rays, in which area they operate. Then you had at last James Webb Space Telescope. Just tell me which are the 3 agencies involved here? ESA, CSA and NASA. These are the 3 agencies involved. Anything if it is related to JWST, it is the most advanced and it has a very strong mirror, this, that, everything will be much better for this, because all those were developed in 1990s. This is developed very recently. Okay, that's it for this class. Thank you.